So, today we're going to solve systems by substitution. So, this is 6.3 in your book. We looked at graphing, we looked at telling how many solutions there are, and now we're going to solve systems by substitution. Substitution is an algebraic way to solve, so we did it geometrically by graphing. It involves replacing one variable with another. We're substituting one thing for another, so you guys can watch this really quick and then we'll do some examples together.
The substitution method for solving a system of equations involves replacing one of the variables in one equation with an equivalent algebraic expression from the other equation. When solving a system by substitution, at least one of the equations needs to be solved for a variable. In this example, both equations are already solved for y, so this step is complete. Since y is equal to 4x minus 7, you can substitute that expression for the value of y into the other equation. Now that you have one equation and one variable, solve for the variable. Subtract 2x from each side. Then add 7 to each side. Divide each side of the equation by 2. X is equal to 6. Now that you know the value of x, you can solve for the other variable y using either of the original equations. Using the first equation, replace x with 6. Y is equal to 24 minus 7, or 17. Finally, write the solution as an ordered pair. The solution of the system of equations is 6, 17.
Alright, so these steps are also written out for you guys on page 341 and 342, so you didn't have to write all this down. So 341, 342, you'll see the steps for this video. But if you get stuck on any problems that you're working on, go back and look at the steps and see what step you're on and go back to that step. So let's look at some examples together. This first one, solving by substitution. Again, we looked at solving by graphing. And sometimes it's kind of hard to see on the graph where the actual point of intersection is. So with substitution, you can get an exact value algebraically. So what we're going to do is we need, in one of the equations, we need one of the variables by itself. Now in this case, we have a variable by itself in each equation. So what we want is a y equals or an x equals in one of these equations. In this case, we already have y by itself. So here's the equation, y equals x minus 3, and the other equation is y equals 2x. So if we know that y equals x minus 3, but y also equals 2x, we can replace the y with 2x, because one of the equations says that y equals 2x. So if y equals 2x, then that means I could replace one with the other. So we're going to replace y with 2x. And then this x minus 3 will just stay here. So now, instead of two equations with two variables, we have one equation with one variable. So to solve this equation, we would subtract x from both sides, and we get x equals negative 3. So with substitution, we turn two equations with two variables into one equation with one variable, which we'll then solve using the methods we learned earlier this year. But then we have to find the value of y. So we can pick either of those equations, y equals x minus 3 or y equals 2x. And now let's plug in negative 3 for x. So if I plug in negative 3 for x, then we get that y equals negative 6. So our solution for this system is the point, since it only lets me do this, negative 3, negative 6 for our solution for our system. So once you have x and y, remember we write it as an ordered pair, x comma y. So why don't you guys try this check problem. Actually, before we do that, let's do another example together. So again, if we want to solve using substitution, then what we want to do here is, hope our computer loads quickly first of all. So we have y by itself, y equals x plus 4, y also equals 2. So if y equals 2, then I could replace this y with 2. And now I have just one variable, an equation with just one variable. So if we subtract 4 from both sides, then we get that negative 2 equals x. So we just plug this 2, because y equals 2, so I could replace this y with 2, and then solve this for x. And we actually already have the value of y, because it says y equals 2. So here's my x value, negative 2, and our y value. Oh my goodness, this thing is driving me nuts. Is 2. So there is our solution right there. So you guys now try that check problem. I want you to go right here and try this check problem. If you don't have your books, it is going to come up in just a second here, so you can pause it and do this. But this is also on page 342. So do this on page 342, and we will go over the answer and check the answer in class. Okay, so hopefully you paused and tried that one. Now let's look at another example. Some equations won't always have, like those first few examples had the y by itself, but sometimes one or both equations might not be written in slope-intercept form. Now, when you're solving for substitution, you don't need to have it necessarily in slope-intercept form, where it's y equals. We just need one of the variables by itself. So if we took this equation and wanted to solve it for x, we could get x by itself, or we can get the y by itself. Now it's going to be a lot simpler in this case to get the y by itself. So whatever variable doesn't have a coefficient, generally that's going to be the one that's going to be easier to get by itself. So let's look at another system where we have to rewrite one of the equations. Or actually, this one already has y by itself, so this one we won't have to do too much work either. So this one is on page 343. You guys can go to page 343 and fill in the blanks for this problem. But what we're going to do is, in this equation, we have y by itself. So in this second equation, I could replace y with the value of y in the first equation. So we're going to take this second equation, and in place of y, we are going to put, is it going to work for me? Where'd it go? Oh, why is this not working? Interesting. Okay, so we're going to replace y, I'll just have to write it, with 3x plus 8. So this goes in the blank. You have 8x plus 4, but in place of y, okay, I'm going to rewrite this equation, but in place of y, the other equation tells me that y equals 3x plus 8. So this means that these two are interchangeable. I can replace any y that I see with 3x plus 8. So this is what you're going to fill in on page 343. And now we're just going to simplify and solve this equation. So our next step to solving this equation is distributing. We'll distribute this 4 to get 12x plus 32 and then we'll combine like terms. 8x plus 12x is 20x. So again, there's a box that you can fill in for this step as well. And now it's just solving this equation for x. Subtract 32 from both sides. We get 20x equals negative 20. And then divide by 20 to get x equals negative 1. So if x equals negative 1, that first equation was y equals 3x plus 8. So I can go to this equation and replace x with negative 1. And this will be negative 3 plus 8, which is positive 5. So x is negative 1 and y is 5. So let's just recap. The one equation told us what y equals. So in place of y, I can put what y equals. And now what we've done is created one equation with one variable, x. And now we've learned how to solve these types of equations. Going through all the steps, we get that x equals negative 1. But with systems, you need an answer for x and for y. So you're going to replace this value for x in one of these equations. You could put x in this equation too, but this one will be a little bit easier to find y since it's already got y by itself. So if I replace x with -1, then we get that y is equal to 5. So the solution to our system is -1, 5. So see if you guys can do the check problem on the top of page 344. It looks just like this. Okay, so if you go to page 344, at the top is this check problem. You guys do this and we'll check this one in class. So pause it, do the problem. And then let's look at one more example. Excuse me. Sometimes we need to, again, get a variable by itself in order to use substitution. So what we're going to do here, this will load for me, is we're going to solve this equation for y, meaning we want the y by itself. So we'll add 3x to both sides. So we get y equals -13 plus -13 plus 3x. Okay. So we get y by itself in one of the equations. And then we're going to do what we just did in the last problem. So in this equation, we're going to replace y with -13 plus 10. Okay, I'm filming while people are awake, so everyone's loud coming in here. I have to keep stopping. So we're going to replace this y with -13 plus 3x, because that's what we got y to equal in the other equation. And now again, we have just an equation with just an x. So we'll distribute the 5 here, and this gives us -65 plus 15x. Again, take your time. You can pause the video if you need a second to understand or go back to a spot. Combine like terms, so 4x plus 15x is 19x minus 65. Then we'll add 65 to both sides and divide by 19. And we get that x equals, I think this is 76 divided by 19 is, I don't even know, 4. So x equals 4. Okay. Now we have one of our variables, but we still need to know what y equals. So we can go to this equation, this first equation, and replace x with 4. And if I do that, we get y minus 12 equals -13. If I add 12 to both sides, then we get that y is equal to -1. So x is 4 and y is -1 is our solution here. So we'll stop with that. See if you guys can do that check problem, but we will also be doing several examples in class tomorrow, but this will at least get you started and kind of get you used to the idea of substitution. Again, go back and rewatch any examples you don't understand. Try the check problem at the top of 345, and we'll go over all these check problems, and then we'll do a few other examples in class. Okay, talk to you later, guys.